In our last video, we talked about relative and local extrema, and we mentioned absolute extrema, but we kind of need to go over it a little bit more. So when we are looking at absolute extrema, we're going to be looking on most of the time closed intervals. The reason why most functions go on forever, and so they're generally going on forever in both directions. So we'll never get an absolute max or an absolute minimum. So when we're talking about those absolutes, we're going to generally have endpoints. So for each statement below, sketch a graph that satisfies the given information. If possible, otherwise write not possible. Okay, the function attains a global minimum, but not a global maximum on the interval 0 to 5. So we get a minimum but not a maximum. So we're going to draw a graph that looks. In order to not obtain a maximum, we're going to generally have some sort of asymptote. So if I have some asymptote here, uh, 0 to 5, that just means we need to be going upwards on both sides when we end at 5. So this function, if I look here, has a minimum, but because it's going on forever, up here we have no maximum, at least globally. The function g of x obtains an absolute maximum, but not an absolute minimum on the interval -4 to 2. This is identical, except for instead of our asymptotes going upwards, now they're going to go downwards. It's not a very good graph to get -4. Put -4 over here, gonna put 2 over here. So we need a maximum this time, so I'm gonna go this way. And this way. We're going to have an asymptote right there. So we have a maximum. This one happens to be at -4, and no minimum because it goes down forever. The function attains a minimum at 2 different values of x, but only one maximum. Generally, if we have more than one minimum, we're going to have kind of like a dip and then it's coming back up. It'll look like kind of a sinusoidal in a lot of ways, but it can be anything between 1 and 8, where we just need minimums and maximums. So if I have, say, my minimums here, I could be a parabola. I could also be part of a sinusoidal, as long as I have my minimums happening at the same spot. For 0 less than x less than 4, so between 0 and 4, the function k of s is continuous but does not have a minimum or maximum value. So this is not possible. The reason why is even if I have a straight horizontal line, we still have something because we have a value. So we can't do this one. Okay. One of the other things that we're going to be talking about is extreme value theorem. Extreme value theorem is also an existence theorem, just like MVT and IVT. So if f is continuous, On the closed interval, and I know it's closed because we have these squared brackets here, A to B, then f has both an absolute minimum value and an absolute maximum value. Every theorem has conditions. We can only apply this theorem if these conditions are met. If conditions are not met, then we cannot apply the theorem. So when we're talking about EVT, we had two things that we had to write down. It's continuous on a closed interval. So our two conditions here are continuous and closed interval. Okay, if the conditions are not met, then we would say there is no guarantee. If the conditions are met, we are guaranteed to have a minimum and maximum. Specifically an absolute minimum or global. We call this an existence theorem. The other two existence theorems we already said are MVT and IVT. Okay, so while EVT guarantees that any function meets the conditions that have both an absolute max and an absolute min, the theorem does not give us any information on how to actually find those values. So we need to find the critical values on the given interval, create a table of values, include critical values, and endpoints. So when we're looking at these global or absolute, we want to include the endpoints. If the endpoints are the minimum or maximum, we need to test them. The greatest value of the absolute max and least value is the absolute min. Give the absolute minimum and or maximum using the following wording. The absolute max is blank at x equals blank. The absolute min is blank at x equals blank. We are going to be writing in the y value for that first blank, the x value for the second, obviously, because it says x equals. So we need to just be a little bit careful on that. We also just need to be prepared for other ways to be asked these questions.